We've got a really interesting panel now on essentially what the next decade of innovation could look like in robots, smart machines, autonomous systems. We know it's a big area of focus for techUK and therefore our members. In September, we launched a brand new robotics program at techUK that will explore the future of these technologies, the opportunities for UK leadership for industry, government, research and academia, and many other stakeholders. So we're really excited about that, so do check that out. And we'll be working with lots of fantastic people on this panel and here today on just what that program looks like over the coming year and beyond. So without further ado, I'll quickly go across the panel and let our panelists introduce themselves. Jenny, I'll start with you.
Hi, I'm Jenny Reid. I'm a Programme Director at ARIA. Those of you who were there in the earlier panel heard all about ARIA from Ant. I lead a programme of research in hardware for robot dexterity.
Thanks, Jenny. Daniel.
Good morning all, Daniel Smalley. So I do work for a German startup, came to the UK, but it was in about 1850. So I work for a company called Siemens. I am business manager responsible for some of our emerging software portfolio, so covering industrial AI, edge, simulation topics.
Julia.
Thank you. I'm Julia Sutcliffe. I'm the Chief Scientific Advisor in the Department for Business and Trade. And I have a background in robotics because previous to that, I was Chief Technologist at BAE Systems in the air sector and have spent a couple of decades and more developing UAV technologies and aerial robotics.
Hello everyone, my name is Jacob. I am Director of Science and Tech Policy at the Tony Blair Institute, an NGO that advises governments on policy. My own background is in systems engineering in Sweden, but I also came over to this country to do a PhD in AI governance at the Oxford Internet Institute.
Fantastic, thanks all. So we're going to jump right in and I think start by talking about the technologies that we are discussing here today when we talk about robots, smart machines, autonomous systems. Jenny, I'll start with you, and I think ARIA's got a really interesting opportunity space in robotics. And are you able to explain just what that is, and particularly why dexterity matters to what we're talking about today?
Yeah, absolutely. So the opportunity space identified in robotics where ARIA could make a difference, I think, is in hardware, because there's so much excitement and so much energy and funding going into AI and control, and I do believe that's going to be really transformational. But I also believe that at some point in the fairly near future, they're going to hit up against the limit of what's actually possible with the hardware that we have today, the actuators, the sensors, and so on. And so what my ARIA program is aiming to do is kind of get ahead of that and fund some work on very early and immature technologies with the hope that in the future, when they hit that bottleneck, that new technology will be mature enough to make a difference and enable innovation to continue. We're focusing specifically on dexterity just because I think that's really fundamental to especially the next generation of robotics. So we're seeing this change from robots that kind of do one thing well, as I think Jonathan was talking about earlier, to flexible, adaptable robots that with today's AI can figure out how to do different things. But in order to do that, you need the dexterity to be able to handle unexpected objects, objects that are soft and deformable and so on. And so that's where we're trying to focus our efforts, because once robots can do that, it will really open up value, I think, across so many sectors.
Yeah, absolutely. That's very exciting. Daniel, I'd like to kind of contrast that to what's coming to what's already around. So how does the adoption of these technologies depend on the digital infrastructure and so be it that already exists?
Yeah, I mean, the infrastructure is important, and it's really important to understand from manufacturing that, you know, a lot of it is brownfield applications. You can't just be ripping out technology and applying new technology for the sake of it. So we're very conscious that we need to work with what our customers already have. So it doesn't inhibit what we can do with the technology, but it does define the start point. So we need to understand where our customers are before we can understand how to take them to the next level. Interestingly, I mean, we do a lot in terms of the industrial space, but we don't make robots. This is one of the things we don't do, but we do a lot of work in terms of the control of robots, the simulation of robots. So there's some key technology in there that we work in terms of helping our customers adopt things like automation and robotics. So things like digital twin, so the ability to really test and simulate what you want to deploy and de-risk some investments in things like robotics. It's been mentioned many times, but industrial artificial intelligence. So we take a very specific view on artificial intelligence around industrial applications. We see some very specific challenges there in terms of how it can be adopted in a manufacturing space because of some of the requirements around safety and cybersecurity and these things that we know need answering. And things like cybersecurity as well, things that we're doing in terms of the deployment of technology. We have to make sure that we're designing it from the outset to be secure. So yeah, these some of the areas that we're focused on, but we see the areas of I guess development on the software side in terms of simulation and control, but a lot more in terms of collaboration with others, specifically on things like sort of robotics and things that we don't do.
Sure, and that's really interesting, and I think cyber will be a big part of our robotics program next year, which is, for obvious reasons. Julia, I'd like to, Jenny earlier mentioned dexterity and the importance of the technologies that enable robotic hardware to be more dexterous. I think mobility is another big one, right? Are you able to speak about how your previous experience has, are those two should they be considered together, or is one more important than the other? Can you talk us through that?
So I think what we've sort of seen recently is a sort of convergence of different sort of technologies that have allowed this sort of expansion of where we can utilise robotics in the real world applications. So the massive advancement in compute power availability and the affordability of compute power has been really, really significant. The miniaturization of sensing technology has been really significant. When I think about some of the early robotics that I worked on 20 odd years ago, it's just light years away from some of the technologies that are out there today and the applications we can see today. Because of that sort of compute baseline and that sort of miniaturization of sensing, you've then got the sort of software side, and the advances that we've seen in AI have been really significant. So reinforcement learning, the ability of systems to kind of sense and be aware of their environment and then act accordingly. We've talked about the sort of observe, orient, decide, act kind of loop, but that's really happening in sort of near real time now. So that's a real advancement. And then the other kind of area I would point to is the sort of material science, and that sort of brings in the sort of soft robotics, where we now move from very sort of, there's a vast range of robotics, but moving into a space where new materials can allow very different robotics applications in different environments to create applications that are incredibly useful is kind of where we are today, I think. So it's a very exciting time.
Absolutely. And Jenny, just to come back to you, is what Julia's saying that we're moving a bit more towards an ARIA opportunity space where there's novel materials and soft robotics? Is that?
Yeah, absolutely. That's part of what we're trying to explore, because I think the new approach to robotics has opened up, as Julia says, all these new approaches where you can now use soft and deformable materials where it's hard to model and you can't really do your inverse kinematics. It doesn't matter so much if you're training it through reinforcement learning. So yeah, I feel like the whole design space has just opened up. And part of the work that we're funding is on developing new approaches for designing robots and trying to move away from what I've called the Darwin paradigm, the Genesis paradigm, towards a more evolutionary type paradigm. So I think traditionally robots have been designed by mechanical engineers and then sort of handed over to a computer scientist to go, okay, you figure out how to animate that. And coming from a background in neuroscience, I'm just very struck by how that isn't how animal bodies work. Obviously, control and bodies have evolved deeply integrated for millions of years. So can we use modern simulation and compute and AI approaches to achieve something a bit more similar in robotics?
Yeah, absolutely. That's fascinating. Jacob, I'm going to come to you now, and I just want to point to a fantastic report that the TBI published earlier this year.
Around this time last year.
I've lost track
with
of time.
Input from Jenny and many other people in this room.
There we go. So in around robotics and UK leadership, in this report you write, improved coordination will be necessary to govern how robotics technologies intersect with one another. For example, how an autonomous ship docks with an autonomous port to offload its cargo to autonomous delivery drones. Is it fair to say that this type of holistic thinking is going to become even more important as we continue to develop these new types of robotics technologies?
First of all, thank you for the close reading. I'm happy that you picked up on that particular quote. I think the general point is this. We have heard from the other panelists how a lot of technologies are evolving rapidly. AI has been at the forefront of that, but also material science, intersection with dexterity and other things. The point is, when it comes to robotics, we will likely have technological capabilities before we have societal innovation that enable their safe deployment. And autonomous cars here is almost a case in point, where we'll probably have autonomous cars that are capable of being implemented before we have safe social structures that allow for them to run on our streets. And the question is even, what should those standards be? Can we just update existing product and safety legislation, or do we need more holistic approaches that looks from a societal perspective? And the reason why we took this particular example is that there are so many different actors involved in such a supply chain, right? So you have the operators of the logistic infrastructure, that might be shipping companies or logistic companies. You have the technology providers, and sometimes you have suppliers to us. And our main point here is that when we talk about governance and government coordination, this is not to be anti-business, this is not to put up new hurdles or punish innovators. It's really to provide that enabling infrastructure. And our view is that today, that regulatory environment doesn't exist that would allow for such a supply chain to come into fruition. I should say one more point on the general topic of how we viewed just the UK's position. When I think both researchers and technology companies around the world think about robotics leaders, I'm not sure UK automatically pops up in top 3. I mean, you would probably think of maybe Japan, maybe Germany, maybe a few other spaces. But I do think that this moment in time, of course, embodied AI is a little bit of a buzzword, but still this moment in time with the integration of new software actually opens up an opportunity and gives UK a second chance with the research universities we have, with DeepMind and the ecosystem that is merging around the area. So I think our message is that maybe UK isn't today viewed as the leader in robotics and embodied AI, but I definitely think that we have the ingredients to become.
Absolutely. You've stolen all my questions for the rest of this panel, but interesting answer, so thanks, Jakob. I'm also going to hand this mic down, so Julia, Jakob, you both have one each. I'll think of other questions. So real-world use cases to kind of ground this a bit more, and where deployment's already happening and what that kind of looks like. So maybe, Daniel, I'll start with you. And I think advanced manufacturing is one area in which the UK is perhaps stronger than other areas of robotics adoption, and maybe what most people think of in this area. Are you able to kind of walk us through why that's the case and give us a few examples of what you've seen at Siemens?
Yeah, I guess when people are thinking about sort of advanced manufacturing, automation, robotics, the thing that kind of springs to mind is like automotive, right? You might think of a Nissan or a BMW, lots of robots sort of dancing around, building cars, welding, all these sort of things. And this has been possible for many years. So, I mean, it's important to understand that when we're talking about advanced automation, robotics and things like this is not new. You can do it. You can do it today. Whether we adopt to the level in the UK, probably not, right? But this is possible, and it's possible today. In terms of applications, I guess a couple of examples, maybe one closer to home and one a little bit further away. So Siemens we make software and automation components to control robots and automate factories, but we're also a large-scale manufacturer in our own right. So here in the UK, we manufacture electronics and drive systems in Congleton, so a small town at the foot of the Peak District. And this is a factory we've had since the 1970s. So it's fairly limited now in terms of the footprint of the factory. It now has houses around it. You can't build up, you can't build out. But they need to maintain their productivity. They have productivity goals 10% a year. So they compete internally within Siemens factories to manufacture products. And we're a high labor cost country. So they use the investment in technology, the investment in automation, robotics to maintain that productivity. So they will really, when they're bringing new products to market, they will design them in simulation software. They will really have a look at, can they fit the production line in the factory? Are the pillars placed in the right place? Because they have limited shutdown to do it, to bring new products to market. So they achieve the productivity in terms of getting products out the door as fast as possible, but they've also had quite stringent goals in terms of like sustainability goals. So getting to become carbon neutral, reducing waste, all these sort of things. And they've used these technologies to achieve that. So they had a target of achieving this by 2030. They achieved it in 2022. So this is way in advance of the ultimate goals. But it's the technology and the investment in technology that's allowed them to do that. Another example further away, and I use this example because I had the opportunity to go to Vietnam on holiday this year with my family and went to Hanoi. If you've been to a city like this, first thing you notice is like the traffic there is completely insane. But one of the things you will notice also is there's new cars on the road there. So there's a company there called VinFast. So this is a totally new automotive manufacturer who started in like 2018. Siemens were working very closely with them over in Vietnam, and their goal was to create a new car, new factory, completely greenfield from the outset, and be like an automotive leader in Southeast Asia. So they worked very closely with Siemens in Vietnam. They really started designing the product and designing the factory while they were physically building the factory to understand, can they achieve what they want to set out to achieve? So using simulation, digital tools, AI, everything to build that. So they ultimately built a factory and produced cars in 21 months after starting. And this is, in automotive, this is like unheard of. So this is, I think a great example of also using technology in a very low labour cost country, but also investing significantly in the technology to achieve that.
Yeah, that's fascinating. The scale of ambition is just incredible, isn't it? Jacob, I think you want to come in on that
yes,
point.
Yes, because I wanted to build on a specific example around automation in factories in that case and advanced manufacturing. I think one of the reasons why so early breakthroughs there is not just that technology is more advanced than, let's say, for example, delivery drones and others. It has a lot to do with the environment. So we often talk about enveloping, so to design a constrained environment in which the technical capabilities are allowed to work out in a safe way. So if you take, for example, the transport system is the exact opposite, where our roads is in quite an organic ecosystem where humans and machine collide for us. But if you think about it, we do enveloping all the time. So the Elizabeth line, it's a constrained and enveloped ecosystem in which the Elizabeth line operates, and it's even shielded so that you can't go down to its rails. And I think that and a society can both be leader in actually developing the technological capabilities. So, for example, what are our automated systems, but also in enveloping the environment in which machines and robots operate so as to allow their earlier and quicker deployment. And I think that is a thing where there is no reason why UK can't lead in its thinking already today to bring that outside the factory floor and into society.
Absolutely. Julia.
Thank you. I just wanted to come in on those excellent points, because if we think about the number one agenda for the government, it's growth. And we think about robotics, there are sort of two sort of application spaces for robotics, essentially. The robotics that enables you to do the thing that you were doing but more efficiently, and then robotics as an actual product outcome itself, for example. On the former that we've just been talking about, the other thing that it allows you to do when you automate is to do smaller batches and to adapt to smaller batches. So if we think about, to resonate with Ian's point, we're a medium-sized economy. What are we going to be doing? What are the kind of products that we can manufacture and outturn? We may have smaller markets, so we might need to think about smaller batches and reconfigurable factories so that we can tune our product outputs. And that is something that you can do efficiently with robotics and automation. And it's less easy to do with a kind of manpower that needs completely retraining in order to create these smaller batch outputs. And when we think about the UK, that is something where we could differentiate if we produced more robotic capabilities for businesses to experiment with and deploy in their production systems.
And just to jump in, of course, there would have to be dexterous robots.
Absolutely.
There we go. I like it. Julia, if we can just stay with you okay, that's, I guess, more niche or kind of smaller levels of deployment for more tailored use cases, but there's also scale, right? Deployment at scale. So can you maybe talk to us a little bit about what you've seen or experienced around, I think UAVs in Ukraine is something that was mentioned on the last panel I was on, but maybe you can kind of elaborate upon just how that, paint the picture for us really around adoption.
Yeah, so I think something like that creates an inflection point, essentially. And what we've seen there is a huge expansion of a UAV capability and an application space. And what's important, I think, for us is recognising the dual use application of that kind of robotics. So we've seen in the UK that we have an uptick in defence spending. It's really important that we leverage that capability and that uptick in investment across the wider economy. And UAVs is a prime example where that can be done. And we see the application of UAV technology for things like inspection, transmission lines, railways, etc. UAVs and autonomous systems have always famously been targeted towards the dangerous, dirty and dull tasks, which are now becoming much more complex, obviously. But in the earlier days, that's what it was seen as. And indeed, for routine inspection and routine delivery and things like that, we are now opening that aperture of what is possible, both in terms of application, but what is possible in terms of rapid development and deployment. So the next phase for us, back to your point, is to think about the regulatory environment that allows us to bring through this sort of era of innovation into the sort of wider economic benefits for the UK.
Fantastic. And we'll come on to regulation, I think, towards the end. So that's a really good point. Jenny, conscious ARIA takes often such a kind of long time span, and for good reason, when it looks at developing these capabilities and technologies. Where does robotic kind of deployment or adoption sit within that time span? Is it here and now, or is it coming quite far into the future?
Well, I suppose the answer is, for robotics as a whole, is both, right? And ARIA's first robotics programme is, I think, focused more on the slightly later generation of robots. I mean, we're trying to bring that future forward as rapidly as possible, and we're certainly thinking very much about what happens after the programme. How does the work that we fund actually get into deployment? This week we've got consultants working with our actuator teams, for example, helping them figure out where the first markets may be, which may not actually be in robotics, right? But you can establish a market and then you have a component that can be used in robotics, just as the electric motor wasn't designed for robotics in the beginning. I think I'm also very interested in adoption. I'm wondering about what we could do to aid that. The spending review allocated money for robotics adoption hubs, which I think is great, but I'm wondering whether there's potentially scope for us to do something around assisting with that. Like one of the barriers, I think, to adoption is not having enough consultants who are skilled to help companies figure out how they can adopt robotics into their systems. And I'm talking about existing robots right now, but maybe AI tools give a way of advancing that. So that's something that I'm sort of kicking around my head at the moment. So I think we're trying to think about the whole pipeline, even if a lot of our effort is necessarily on relatively low TRL and early aspects.
That makes sense. That's a good answer. Brilliant. So the next part of this discussion is how can the UK place ethical safety and workforce implications at the heart of deployment? So, Jack, I'm going to come back to you, and I'm going to quote you again on your report, if you don't mind. So one theme of the report that you mentioned earlier was addressing social attitudes. You write, for example, YouGov data show that most Britons say they would feel unsafe in a self-driving vehicle, and public opinion on this has not changed significantly in the past 5 years. So my question is, what more should industry and government do to build up this kind of culture of awareness and acceptance?
The good news is that we have new data. The bad news is that the data hasn't changed much.
Okay.
So we published a study with Ipsos on general attitudes in the UK towards technology and AI a month back before Labour Party conference in Liverpool. And just to give you a few top lines. Number one, twice as many Britons view AI primarily as a risk to the economy rather as an opportunity, so 40% versus 20%, which is huge if you think about the moment we're in and the opportunities ahead. The second is that the lack of trust in technology reliability is the single biggest barrier to adoption. So more so than lack of skills or access or cost. And I mean, if you think about that for a moment, we're investing quite a lot in skilling and infrastructure investment and so on, but actually people feeling, I can't trust this. Now, from a government perspective, there are two tasks. The first is to ensure that the technologies are actually trustworthy. And a lot of this has to do with good sound engineering practices that actually happens inside organizations like companies like Siemens and other already. And there might be elements of regulation coming to that, and we will discuss that. But the government also has a role in shaping healthy public attitudes towards technology. And sometimes this is viewed as a controversial point. It said, should the government really do propaganda around, let's say, robotics and AI? Well, take vaccines as an example. Just like we have to ensure that the vaccines are effective, we also have an educational and communicative obligation to talk about why vaccines are needed and why they are a net positive benefit. So if we go into some specifics here of risk, first of all, because we have software in embodied AI and robotics, all the normal risk of AI applies to robotics as well. So failures of robustness, bias and discrimination, technology failure, and privacy risks and so on. But we also introduce new risk of physical harms, of accidents, of collision, of a malicious use, of terrorist attacks, of backdoor cyber hacking. So I think that wherever we are facing right now in terms of public debate about AI regulation will only become more intense and also more impactful for robotics. The good news is that we have more existing structures to build on. So there are emerging structures for classical robotics, for autonomous vehicles, for agentic AI that we can learn from. The final thing I should say about the labor market impact, and then I'll hand over, is that robotics has probably a higher scope of automating existing job forces and the existing LLMs that we're seeing and that are currently being discussed, that are primarily operating in the face of language. This is not a negative thing. So if you mentioned the UAEs in Ukraine, the fact that we have drones fighting instead of soldiers and human life being killed is a good thing. The fact that we can free up workforce to focus on more creative tasks is a good thing. And maybe the way we should think about this is take, for example, we talk about household robots. All of us have dishwashers at home. We appreciate them. They save us time. We focus on saying, we don't say it's a sad I don't have a maid at home. Like, for example, I lived 2 years of my life in India and my wife is from Delhi. I did have a maid at home who did my dishes. I'm happy that we can free up that labor to focus on more productive tasks, and I hope that will be true in all parts of the world in the future as well.
That's a really interesting way of looking at it. Julia, I'd like to come to you. So on the theme of trust, how do we build that trust, I think, in particular between the operators of the robots and of the systems and the robots or systems themselves? Are there some sorts of frameworks or other approaches that you suggest?
So I think ethical frameworks around sort of robotics and the adoption of robotics are really important, particularly for safety critical tasks, clearly. And there are a number of initiatives that are being established and that exist today where that work is being sort of pushed forward. I think a broader context for this question is around, for me, around the growth agenda that this government has. So if I think about that, I think about what technologies have we got, what infrastructure do we have, whether that's digital, data or physical infrastructure, what's the regulatory environment we have, what is the access to export markets, what's the financial institutions we have, and what is the level of public trust. If we want to take technology and turn that into tradable outcomes in a competitive environment, and that is ultimately this government's goal, then we need all of those things to line up. So work with the regulatory bodies is absolutely critical. So the Regulatory Innovation Office has been set up in DCIT to drive forward that sort of passage through a regulatory framework so that we can get some of these new technologies and applications into kind of into the hands of sort of experimenters in sandboxes, but also then into applications in the public domain. And through that, start to build up the trust that is needed for widespread adoption. And, you know, we're seeing with things like companies like Wave, for example, we're seeing the sort of use of autonomous vehicles on roads being tested now. This is a long way from where we were sort of a couple of decades ago. And I sort of see that pace accelerating now. And particularly as we think about aligning those levers that all need to be aligned in order to get things into the public domain, I think that's a really important task. Lots of barriers in the way, but the opportunity is really significant. And look, it's happening around the world. So we need to capitalise on the brilliant research base we've got, and to Ian's point previously, turn those fantastic ideas and innovations into commercial outcomes. And if we don't, someone else will.
Absolutely. And Daniel, I think this is where it'd be good to get your take. So if a lot of this, the development of these systems is being done by engineers, highly technical work, and then we want to get it in the hands of industry before getting it into the hands of end users, how does that engineering to industry kind of link look? Is that something you kind of have explored much at Siemens? Any challenges or opportunities around that? Talk us through that.
Yeah, I mean, this is one of the key challenges. New technology is only successful really when it's been deployed and it's been scaled. Otherwise, it's just something clever. So that deployment is critical. But what we're talking about with advanced automation and robotics is complexity. Right, there's complexity inherited within it, and this is what slows down adoption. So where we can use things like AI to lower the barrier to entry and support humans in terms of configuring, deploying, managing these systems, this is where ultimately it becomes really effective. There are, I guess, three main things that we focus on from a Siemens perspective in terms of the adoption of industrial AI. One is trying to make it industrial grade. So what we talk about there is it's been mentioned a couple of times, trust, right? We're dealing with safety systems and things like that. We ultimately need to build trust into it. This isn't the adoption, just applying ChatGPT to engineering processes, right? There are very real challenges there, hallucinations, things like this. From an engineering background, it's not a hallucination, it's a mistake, it's a defect, it's wrong, right? And you can't have it within engineering. So you need to be able to use the power of the tool, but tailor it towards specific tasks to make sure we can do that. The other is around making it accessible. So really making it accessible to humans, making sure people have access, and it's supporting what you're doing in other operations as well. It's no good having something that's complex, outreach, expensive, all these sort of things. And finally, it is really about building ecosystems around that to deploy it. Because it's not a task just for Siemens. We're a big organization. It's not just a task for a Microsoft or an OpenAI or whoever. This is really about building stronger ecosystems around the technology provider, the cloud providers, the data science, the research organizations. How are we really working together on a task rather than doing our little bits in silos and seeing each other as competitors?
Absolutely. And as soon as we hear the word ecosystem at techUK, we think, that's us. So very happy to help. Jenny, a question for you and Aria's work in robotics and hardware and dexterity. How do you bake all the things we've just been talking about, so safety and ethics and trust and workforce considerations, into the work that you're doing?
Yeah, great question. So I think the core of the work is focused on the technology and trying to get that up and running. On the safety and trust, I would like to highlight a couple of other ARIA programs that are highly relevant. So my fellow program director, David Dalrymple, has a program, Safeguarded AI, which I think is really fascinating. And that's looking at how you address this problem. Right? If future robots are going to be using AI and neural networks that have learned to do a task with millions of weights and no one really understands quite how they work, how do you put guarantees around their behavior? And I think a lot of people would say, well, you can't, it's impossible. But Davidad reckons there is a path using a lot of very clever maths and category theory to doing that. And so that's what his program's about. And obviously I'm extremely interested in that because if it works for AI in general, of course, it'll work for robotics as a subset of that. And then our second cohort of program directors includes Alex, who's developing a program in an opportunity space called Trust Everything Everywhere. And I think that, again, is really exciting because if you think about future robots and a future of ubiquitous robots everywhere, drones, delivery, the coordination that you were mentioning in Jakob's report, we're going to need guarantees and we're going to need to be certain that those haven't been spoofed so that you can trust a robot when it says, I meet this standard or I have carried out this task. So again, Alex is looking at new approaches for guaranteeing that, perhaps using quantum approaches, perhaps using hardware guarantees, so the unique signatures that individual atoms or, sets of atoms provide. So if anyone's interested in getting involved in that, bit of a shout out for that program, it's under development, so reach out to Alex. So even though that isn't something I'm working on myself, we're within this ecosystem where other ARIA programs are addressing that. I've allocated some funds within my program. I haven't actually put a call out yet, but I do want to think about trust and public adoption. So part of it is I think about storytelling. I feel like we don't have any great stories really about the kind of robot future we're trying to get to, maybe especially in the West. Maybe I've heard that in Japan there's maybe more positive attitudes, but I feel like I could name you any number of robot dystopias, but rather few kind of robot utopias. So I feel like I'd like to commission some storytelling work about where are we trying to get to, what would it look like? I think there's great stories to be told, especially about Britain. I live in Newcastle upon Tyne, such a deep, rich history, the big first industrial revolution, a lot of it happened there, the steam engines, the railways, and now we're entering a new industrial revolution, and we want to be part of that. And just as Britain became very rich and powerful because of the first industrial revolution, we can have a rich and prosperous future again now because of this new industrial revolution that we're all standing in front of. So I really want to kind of tell that story and get people excited about that future. But I'm also aware that maybe some of the reason people aren't too enthused about new technology may be because of that history. So actually, if you look at that first industrial revolution, it did bring a huge increase in prosperity, obviously, but it also led to bad outcomes for lots of people. And the sharing of that prosperity did not happen for decades, 100 years. People lived their entire lives not seeing those benefits. We don't want that to happen this time round, obviously. So I'm also interested in, can we commission some work at ARIA about what are the options available to governments? It's not our role to propose policy, but just what are some of the options available? What are some of the strategies you could take to ensure that the productivity gains get shared fairly and everyone sees the benefit? And at this time round, we do industrial revolutions a little bit better than maybe we did in the past.
That's fascinating. Jacob, go for it.
Yeah, let me jump in there. So first of all, I agree 100%, and I would almost say that is our core problem statement at the Tony Blair Institute. How do we transform government in the age of AI and robotics? Because if you think about the transition from feudal and agriculture to the industrial, it took the social innovation, social institutions, decades, if not 100 years, to adapt before we have minimum wage, before we had benefit sharing, before we had child working regulations, before we had universal franchise for women voters and so on. And I think just like that transformation was one of the state itself, that will also happen now. So it's less about how can the industrial state tweak its policies on the margin. Let's say, for example, how do we change the curriculum from not including AI and robotics to include AI and robotics? Or how do we rescale the current workforce to be better at using AI? It's really to say, what should taxation even look like in the world where we can automate a lot of value production? What is the ownership model of these capital-intensive resources in manufacturing? The civil service, what makes sense in terms of headcounts, in terms of tools, and so on. So I think that we're going in for a very radical period of transforming center of government, and that is what will be needed in order to make sure that, you don't have to use Blairite language around the third way, but in its essence, what we want to do, we want to push the frontier on science and innovation and economic growth while making sure it's widely distributed and protecting against large-scale failures.
Amazing. Well, some big questions that go well beyond robotics, but all ones that techUK will be exploring next year, so please do check out our work in Emerging, Converging, Transformative Technologies, is what we're calling it. So great. I'm going to move us on to the final section, which is on infrastructure, interoperability, regulation. Julia, I'll come to you first. So I think something that maybe Jenny mentioned was a previous panel? I've lost my bearing of time. The Robotics Adoption Hub Network, the £40 million through the industrial strategy allocated to driving robotics adoption in the UK. Can you talk us a little bit about that and what you expect to see from that investment?
So I can't give you lots and lots of detail on that because it's yet to be publicised. However, If we take a step back and just think about why we are doing this, so look at the industrial strategy, look at the 8 sectors within the industrial strategy, so advanced manufacturing, clean energy industries, life sciences, creative industries, defence and security. These are all rich opportunity spaces for robotics. You've heard the government's agenda is about growth. You've heard Ian talk this morning about transitioning those government priorities, that applied science, into growth companies and applications that can benefit the wider economy. And we've talked about some big questions this morning, but if I narrow it down to the kind of next 10 years, that's what the industrial strategy talks about. We have a huge imperative to deploy the capability that we have nationally and drive out growth across those sectors. That really is the key thing that we are sort of talking about in certainly in DBT, the Department of Business and Trade, with the Treasury and with other partners across government. And it brings in infrastructure, it brings in regulation, it brings in skills, it brings in all the things that we've been talking about this morning and how we integrate those and synchronise them so we actually get away from the sort of small amounts of funding to do really interesting things and focus now on, we need growth in the UK. We need to use technology and the brilliant baseline that you have created to drive the economy forward in this next phase. It is a really exciting opportunity. Government is trying to pull all those levers together, but it needs to be a joint government, academia, industry operation. We all need aligning. We can create growth across the UK if we all act cooperatively. It won't be simple. If it was simple, we'd have already done it. So it's complex, it's challenging, there'll be hurdles and barriers in the way, but we need that really close dialogue to understand where are those barriers and how do we get over them. We have a paucity of robotics deployed in the UK. We need to fix that. We need to just address that. So to Ian's point, let's be really focused about the things that we're going to do, why we're doing them, and the outcomes that we want. And so the robotics hubs across the UK is part of that answer. There'll be lots more detail as DSIP publishes the detailed plans for those, but it's about kind of addressing all of those topics that we've talked about, addressing the trust issue and addressing the just how do industries get involved with technologies that are already out there and start deploying and using them so that we can leap ahead as a nation and create the growth outcomes we need.
Amazing. What a call to action. I feel like we should end there, but we won't. We've got 5 minutes. So Daniel, I'm going to come to you. And Siemens, as an organisation, as you said, has been around a long time.
Yep.
And by the way, bit of a random plug, but if you're in the cloakroom today, check out the plaques on the wall that set out how Siemens was founded and has grown over the 100 and whatever years since. It's called the Siemens Room. That aside, what's your take on? I think in particular what Julia just said, and kind of seizing the opportunity and learning from, building upon existing technologies, but investing in future ones, leadership. What does that look like from a Siemens perspective?
Yeah, I mean, these were really good points. It's not all about future technology, right? A lot of this is known and proven. There is no debate in Japan or Germany or South Korea about the use or investment in robotics or advanced automation. There isn't. It's done. They're settled and they're doing it. So we're behind already. The advantage, if you look from the positive angle of being behind, is there is now newer technologies to make that adoption easier than they had it, right? So we need to focus on saying, okay, this is the right thing to do. How do we do it quickly? How do we scale? How do we deploy? How do we use the innovation, the regulatory support and ecosystem that we have to speed ahead and deploy things that are then more advanced? But the debate is, it's not one to be had. This is the right thing to do, and it used to be purely about productivity. How do we make things faster? But now it's more around the product mix, mass customization. It's around addressing skills gaps. It's addressing the fact that we don't have cheap labour. It's addressing a lot of these things that benefit UK PLC.
Sure. And to be clear, are you saying there's an opportunity to kind of leapfrog potentially, to go from behind to in front, or just to catch up?
No, I think there's an opportunity to leapfrog. So a lot of the innovation that we see within Siemens is how do we automate automation? How do we use AI tools to automate what we're deploying? Because it's hard, and people that have come before us have had to spend a lot of time and a lot of money building these systems. When you see a complex car factory and things like that, an awful lot of work has gone into producing that. A lot of mistakes, but they made a lot of learning. We have access to that learning, and we have new tools to be able to support it. So there should be a greater opportunity.
Yeah, absolutely. Brilliant. Jacob, I'm going to quote you for a final time from your report. Hope you don't mind. One second, where are my notes? So in your report, you call for the Regulatory Innovation Office to, quote, set the deployment of robotics, including self-driving vehicles and drones, as a strategic priority, end quote. Can you explain why it's so important for the regulation piece in all of this, and in particular, I think, the coordination of regulators to get the adoption of these technologies right?
So I started out by saying that regulation often can have an enabling effect for the technology ecosystem and innovation. And we truly believe that. That both has to do with, for example, harmonized standards. If different parts of the supply chain know how to work together and be interoperable, we will see more business, fewer vendor lock-in and so on. So that's a good thing. But it also has to do the trust element, which we heard before. People will only use the technology if they trust it. So we also need to have basic standards in order for people to trust the technology and, again, want to use it. However, we see also big risk, especially for such a multidisciplinary field as robotics that draws on software, hardware, different sectors, and that this can easily become a patchwork of legislation that make it very cumbersome for any provider to bring anything to the market. And the UK has a sector-specific approach to AI regulation, which we support and think is a good idea. When it comes to robotics, this will become a little bit of a challenge because a lot of these material science innovation, the software innovation, the dexterity will be cross-cutting. So the key question here is how do existing regulators coordinate? Whether that is between areas like healthcare and transportation, or whether that is in the stack looking more at model provider and application use cases, or, for example, data. One of the things that we have proposed is to look at, if you take transparency as an example, you can have regulation at the meta level that gives each provider an obligation to say, what are the capabilities of your products? How has it been developed? What is its limitations? And that has to be very clearly communicated to the next provider in the chain or partner so that they can make rational choices based on that information. We haven't reached that stage even for AI models themselves, much less, I think, for the full supply chain. To add further to this complexity is that this is an international ecosystem. Just as no country will have a fully sovereign AI stack, it's unlikely to have a fully autonomous robotic stack. Therefore, we will also look at international harmonization. So the regulatory innovation doesn't just have to do with coordination between regulators in the UK, but globally. Where the AI Security Institute now has a key role is that we have the best funded AI Security Institute in the world. So UK is already a leader, has the opportunity to shape standard, if not to set them. And I think that there will be a natural evolution building out from some of that early work on agents to also look at embodied AI systems in the real world.
Fantastic. And would recommend after lunch staying around for Lord Willits and his Regulatory Innovation Office fireside chat, where we'll be talking just about that. I have a final question before we hand over to Laura for the quantum panel. So Jenny, how important I think is interoperability in all this? Because I think the danger is we have lots of conversations about lots of technologies, but they never talk to each other, and we never realize the benefits that we're all kind of envisaging.
Yeah, I think you've put your finger on it. In order to see those benefits, we're going to need interoperability. We're going to need robots from different manufacturers to talk to each other and understand what they're doing. And also in terms of components, I think we want the USB moment for robotics, really. We want to be able to assemble robots from modular components and have them talk to each other and understand how they fit together. And this is something that's on my mind a bit because, again, thinking about how is what we're funding going to have impact, we're looking at things like tactile sensors, but how do you fit that onto a robot? How does the robot brain and control system know how to interpret that information? We're going to need new systems, new APIs, maybe for new latent spaces, perhaps in AI terms, to enable that interoperability. And I think some of it's happening already. So as robots become more capable and more ubiquitous. You know, we're finding things like the warehouse company has got like one set of robots that are maybe moving pallets around, but maybe they also want cleaning robots, and those two robots need to communicate with one another. So I think something of an ecosystem is emerging on that, but it is going to be critical. And so while I don't necessarily see it as core ARIA business, we're definitely trying to do what we can to encourage that. And we recently published a position paper on interoperability, modularity and standards, aiming to be a contribution as pushing that conversation forward a bit.
Amazing. I love the USB moment for robotics quote, and I also love the idea about telling stories in robotics. And I think maybe next year we'll have a story time with me and a few others, and we'll just tell stories.
Awesome.
And just finally, before I hand over, it also reminds me, as a colleague a few weeks ago went on a trip to China and was staying in a hotel and ordered some food through room service. A robot shows up at the door and somehow knocks the door, I don't know how. And then he followed the robot into the lift. The robot called the lift opened, and they all kind of like talk to each other as they go down the corridor, basically, the robots. So just bizarre, but is happening and could happen here if we grasp the opportunity, I think. So optimistic note to end on. Can we have a huge round of applause, please, for our panelists?